September of 2012, we left our home port of Seattle on a trip around the world in our Nordhavn 52 Dirona. Hello from Nordhavn 52 Dirona in Amsterdam. After cruising Finland, Sweden, and Denmark this year, we'll be spending the winter in Amsterdam before heading south to the Mediterranean next spring. And while we'll be here, we'll be getting a few boat projects done. If you'd like to learn more about our round-the-world trip, we post frequently to mbdirona.com about the cruising lifestyle and the places that we've been.
Today what we're going to do is change a steering component. This is what we're changing today. It's a spherical bearing, or also referred to as a rod end. The hydraulic steering, driven by the wheel or one of the autopilots, pushes this back and forth. This runs the rudder to side. The one that's downstairs today is worn. We're going to show how that gets changed and how you find out if it's worn sufficiently to need change. This is a key component because if it fails, of course, the boat's at risk and you may lose steering. Probably the easiest way to show how this works and get into some of the details is to head down below. So let's do it. All right, here we are in the lazarette of Dirona. And this is the steering control system here, the steering assembly. First thing you'll notice when you look at this is it's heavily built. This is stout gear. This particular boat has a bearing at the top of the rudder. And the rudder shaft is here, so there's a bearing at the top. And there's a bearing 6 feet below us, and the rudder is held between rigidly. It's possible to build strong boats where the rudder is only held at the top, there's only a single bearing. But this is just a little bit stronger, a little bit more heavy. That's the way we like it. In fact, Nordhavns generally are overbuilt boats. They're designed to be operated, and they're designed to cross oceans and to be safe crossing oceans where the weather conditions you may encounter are unpredictable. And so they tend to the overbuild side. As an example of overbuild, this is a 52-foot boat, and it's a 55-ton vessel. So displaces 55 tons. It's heavy in just about every way. Generally, it's exactly the way we like it. What we're going to look at today is replacing this bearing right here, and I'll show you how we know that that's sufficiently worn to require replacement. But before we start on that, let's look at a couple things that we've changed on this boat as a consequence of learning over the last few years. The first thing, as I mentioned, is there's bearings at the top of the rudder assembly and then down below. This bearing right here, you can just see that bronze segment right there. The original bearing in this boat was Delrin. That's a plastic material that has very nice anti-friction properties, but it wore out in about 1,200 hours. So what we decided to do is we went with a design that is exactly modeled after the Delrin component, but it's made out of oil impregnated bronze, and it's otherwise dimensionally the same, but it's a much stronger material. Although it doesn't need grease technically, we've also put a grease fitting into here so that this bearing can be greased as well. And if you look carefully at it, you'll see there's a grease line all the way around it. So the grease goes all the way around inside the bearing and gets conducted to all the surfaces. As I said, technically not required, but what I was looking for is a way of minimizing the wear on this. As a consequence, this is about 7,000 hours on this component. Had we continued with the Delrin parts, we're now at 10,830 hours of operation. We would have replaced that Delrin component 7 or maybe even 8 times. So we're glad we went with this change. Here's another change we went with. This large bolt right here used to be a little bit shorter, and it was held in place by a cotter pin through one of the faces. It's a perfectly fine way to attach the rudder arm, but over time it caused us a problem. For background, it's vital this bolt be very tight. The loads on the assembly are massive in rough seas, and of course it's very important that the bolt not come loose. The cotter pin completely solves the second concern, but it actually can lead to a problem with respect to tightness. As a boat operator, I know the correct tightness for this assembly is when the bolt head lines up with the cotter pin hole and the cotter pin can be slipped in. Since I need to replace this assembly every 1,500, maybe 2,500 hours, I've done it quite a few times, and I think nothing of it. But perhaps due to repeated disassembly and reassembly, or perhaps due to manufacturing tolerances on the spherical bearing changing over time, this assembly ended up much less tight. It was still snug, and the cotter pin was installed in the right place, so it seemed properly installed. But it wasn't as tight as it should have been. We crossed the North Atlantic in 2017 on the early side of ideal, and unsurprisingly, we encountered some rough water. On the morning of May 15th, 2017, we were operating in roughly 20-foot waves on the aft quarter. Waves from this direction tend to try to force the boat over on its side and as it slides down the wave. The autopilot fights this and keeps the boat on course, but it does mean the rudder is working incredibly hard. In these conditions, it's actually fairly noisy near the steering gear as it creaks under these massive hydraulic loads. When I came on watch at 5 a.m. this morning, I did the usual inspection of the mechanical spaces and the fuel transfer that I normally do at the beginning and end of each shift. This is a normal part of the day on Dirona when we're at sea, and we rarely find anything that needs attention, but still, it's worth doing. This morning was different. The steering system had been working incredibly hard all night, and underneath the rod end I found a pile of ground up metal nearly an inch high. At this point, we're close to halfway on this trip across the North Atlantic. We've traveled 1,350 nautical miles so far, but we still had 1,440 nautical miles ahead of us. It's fairly clear that this rudder bolt was not going to be able to finish the trip. What's happened here is the rudder bolt was not sufficiently tight due to the cotter pinhole lining up at less than the correct amount of torque. This may never have been detected, but we ended up seeing fairly rough water, and it's the rough water that causes the rudder to work hard, and it's when the rudder is working really hard that this wear starts to take place. It just takes a small amount of flex to begin the wear. Once the wear begins, the assembly gets a little bit less loose, and as the assembly gets loose, the wear accelerates, and by the time I got up that morning, it had piled up as deep as you can see it in the picture. This was a fairly serious problem, since without that rudder bolt, there's no steering. It looked serious enough to me that I contacted the manufacturer, Nordhavn, via sat phone and asked for some help. Justin Zumwalt and the folks at Nordhavn were amazing. They jumped on the situation and inventoried the entire boat parts list before announcing that one of the exhaust bolts they'd used high up the stack was of the same size and might be able to get us back to shore. That's pretty impressive service, given that our boat left warranty 8 years earlier. Later, Jennifer recalled that I actually had purchased a spare bolt some years back, and we had it tucked away in our spares. That's a real relief, but it's still a challenging part to change in 20-foot seas because of the massive load on the rudder. Once we got that done and torqued up properly, there was again no wear, and we haven't seen any wear in the 2,000 hours since that time. With proper torque, this bolt can last the life of the boat. The design change we've gone with is one where it's longer so we can double nut it, and so we do this up to 250 foot-pounds torque. That is very high amount of pressure, and that means that it's rock solid and absolutely cannot move at all. Then we Loctite the second nut on there and do it up to 250 foot-pounds as well. So what we're going to do today is see, first of all, if I'm strong enough to be able to undo 250 foot-pounds, and then assuming we succeed at that, I'll take these pins out, I'll check for wear in here, and I'll take this off and replace this section right here. These parts are easy to fool you. You can grab this and say, wow, that's my full strength on there. It feels like it's strong, it's solid, it's showing no wear at all. But it can fool you. If you get underneath it, you see that flex in there? That is completely worn out. And so even though it looks solid, you can see that slight amount of motion. And whenever there's any motion in there at all, and this on a critical component like this, it really needs to get replaced. What does happen is they slowly wear, but in the act of wearing, they start to get little bits of debris in the bearing, and it starts to accelerate. And so once it starts to show wear like this, it usually gets worse relatively quickly. So you want to get on it and change it right away. Now, before I do that, we've got another little change coming up. These bearings are supplied by the hydraulic equipment manufacturer, in this case Teleflex. And they're perfectly good spherical bearings. But a friend of ours, Peter Hayden, who is another Nordhavn owner, found a replacement part that's dimensionally identical, but potentially much stronger. For those of you that are familiar with sprint car racing, it's a popular form of racing in the United States where 850 horsepower alcohol burning cars scream around small dirt tracks at speeds approaching 150 miles an hour. Some of the worst accidents you've ever seen in your life, and these components form the steering, support the steering components on sprint cars. And it's amazing the loads that they can take and keep on working. I've seen cars drive away from flipping 4 or 5 times, landing on their wheels and continuing in the race. These are strong, so we're really glad Peter found them. These particular components are FK bearings, and the model number is SJF 12T. I bought these from Summit Racing, which is a sprint car supplier. And it's a little bit of a test for us. We think this bearing will probably last better, but we'll wait and see. But other than that, it's dimensionally identical. Another thing we've learned that you need to look for is the way these bearings work is there's no lubrication in them. The anti-friction material is PTFE, which is commonly referred to as Teflon. The beauty of Teflon is it's very slippery and also reasonably strong. But it's sensitive to, if any debris gets into here, if anything gets in here, it can wear the bearing out quite quickly. And so here's an example of a new bearing in the package. And if you look at it carefully, you'll see a manufacturing problem. There's little tiny bits of metal in there. That's not a disaster. It'll probably last hundreds, if not 1,000 hours or more. But those little bits of metal will accelerate wear. And so what we need to do is make up for the manufacturing mistake or sloppiness, if you will, and get those little pieces of metal out of there, which is not hard to do. I pick them out with a little toothpick, and then blow it off with compressed air and get them nice and clean. And so here's one where I finished getting it the way I want it to look before I put it on the boat. And this is the one that we're going to put on today. I think it is time to do the work, so let's go ahead and change it now. All right. First, an apology. I'm sure I'll hear about this. I'm using quite large adjustable wrenches. And whenever you're using an adjustable wrench, you're proving yourself not to be a real mechanic. The reason why I occasionally do it is for very large bolts like these, nuts and bolts like these, I just don't have the space on the boat to have all of the different tools necessary. So I will occasionally use adjustable wrenches and hope that I don't get struck by lightning.
And what would be the right tool to use for this?
You'd really want to use a spanner, but an example of I have one that's of the appropriate size. You'd need 2 or 3 to do this job properly of this size, and it's kind of inefficient to have that much weight and space taken up on a boat. So what we'll do here is get to work. This is the first thing we'll be changing or not changing, but removing is that lower lock. There we go. So what we're looking at there is, even though I've got a lot of leverage at more than a foot on this, it's still quite difficult to get it free. It's going to have to be slowly worked off the whole way because I use Loctite on these, which makes them more difficult to change. But on the other hand, absolutely will not come off no matter what. Okay, so that's almost off. The next bolt above that, the next nut above that, is similarly tight. It's 250 foot-pounds plus Loctite, and so it'll be a chore to get it off of there. The reason, the other aspects of this that's important is this is fine thread grade 8 bolts, and because of that, they can take a ferocious amount of torque. The reason why you want upwards of 250 foot-pounds of torque on here is if there's any movement in here at all, wear will set in very quickly, and that can be extremely bad. Just before taking off this last nut, I should mention to you, if you look carefully, you'll see a pile of dirt down here. I'm normally quite careful about keeping all the mechanical equipment sufficiently clean. I like everything clean, on the argument that if it's clean, any fault at all you'll see right away. This is a case where I actually intentionally leave it dirty. What happens as this bearing wears, it leaves little bits of PTFE or metal down below, and if that starts to get serious, you can spot it right away from a long way away, and what that tells you, time to change that bearing. So once I get this changed, I'll clean this up perfectly, and then we'll get a chance to watch how it wears over time. Time to get that last 250 foot-pound nut off of there. So that's the rod end off, and you can see quite loose, definitely needs to be changed. Now what I'm going to do is I'm going to pop it back on there briefly just to hold it still while I work on the other component that needs to be loosened off. So I'll grab a hold of the rod end with one wrench, and then loosen off with the other. Again, there's Loctite on here, and so it won't back off quickly. Okay, so there's the new part, and I'll endeavor to keep it clean. Well, this occasionally does happen. I talked earlier about design changes, and I think some of these design changes are really good and they actually make the boat substantially more reliable. I'm happy with them. But whenever you do something that's different, there's always a chance to run into problems. And this, unfortunately, is more realistic than I like. Here's the part that we're so happy we got. It's a little bit stronger, a little bit better. And here's the part I just took off. you can see that they are identical in almost every way. The almost is right there. The threads aren't quite right, and they're not right at all. And so both of them have the same size spherical ends, but the threads are wrong on this new part, so I can't use it. However, the key to running an ocean-going boat is finding ways to make things work. And we do have a spare hydraulic cylinder in the master stateroom, tucked away under the floor. I just went in there and removed the rod end from that, and it is identical to the used one. You can see the same thread, same everything. So we do have the right part here. It is brand new. It's beautiful and tight, and so we'll continue with this job. I need to find a source of this particular part, or I need to find a better part if I can. Likely at this point, I'll stick with this one and just try to get a couple more of these. So let's get this tucked away and see if we can't get this job complete. So when I backed off this thread, I backed it off about a half turn, so I'll be running this down to exactly the same place. And so now bump that in. So that's the lock nut. I can tell because there's a little bit of Loctite still on it. And so it's slightly easier to use the other one because it'll run up all the way, where this one's got Loctite on it. So what I'm first going to do is I've just got that held in place. I will put a wrench around the rod end to keep it in place, and tighten up that lock nut on it. Great. Now what I need to do is we're going to torque this down to 250 foot-pounds. Just to give you an example of how much force that is roughly, a cylinder head on a V8 Chevrolet is held on by something around 110 foot-pounds, 120 foot-pounds of torque. So 250 is very, very, very tight. The reason for that is if there's any play in this assembly, it'll wear very quickly, as you saw in the picture I showed you a little bit earlier. So what I'm going to do is go get a torque wrench, get the appropriate sockets, and get ready to torque this down to 250 foot-pounds. Here I've got my torque wrench. This is the biggest I've got. And the reason you're going with the biggest is because it's a lot of torque. And I always keep these at 0 foot-pounds when they're stored. And so we're going to first turn it up to 250, which will be a long way towards the end of the spectrum.
Now, is 250 a manufacturer's recommended spec, or is that a number that you came up with?
It's a good question. It's a number I came up with. The reasoning behind it is the tighter this is, the better it is. And so what I did is I looked up the maximum torque specification for a grade 8 fine threaded nut, and then used that.
So it's basically the maximum it can take.
It's the manufacturer's recommended max for that particular bolt type.
Gotcha.
Oh, and it looks like 250 is a good choice because the maximum torque for this torque wrench is 250. So there's the limiting factor there. 250, finally. $250 is a lot. So I just need to get a little bit better angle on it because I'm not pulling 250 yet. Wow, that is really tight. Do me a favor. Just reach. I'm going to reach past you and grab something.
Oh, yeah.
Get a little more leverage.
That's the idea. Wow, I'm going to need yet more again.
Do you want that longer aluminum pipe?
Probably. Let's just see how this does. Okay, well, I'm not going to get any stronger, so we're going to go for more leverage.
Yeah.
You see what's going on there is, even though I'm not working nearly as hard as I was before, you can't beat leverage. And so that's now done up at 250 foot-pounds. Next, what we're going to do is get a little bit of Loctite on this nut, this second nut. And this one, because it was on before, it's still got a little bit of Loctite in it, and so it's got higher friction to run it up. I'm perfectly happy with that because I don't want there to be any chance that these ever come off, because if this comes off, the boat loses steering. So I've got the patience to go slow on rolling this up. Put the Loctite away so it doesn't harden up.
Seem to have a lot of those little red rags about.
Oh yeah, they're wonderful. We used to use a lot of paper towels, but now what happens is a very small amount of not a small amount, but a bundle or two of these red rags. They last a long time. We throw them through the wash, and then they're back in use again. So work out really well. We basically almost use no paper towels at this point. Okay, so here's a little bit of a problem for us. When the second bolt is on there, there is no clearance for the torque wrench, and so I'm unable to put torque on there. Strictly speaking, I should have been torquing on this one previously as well, but what I was doing is pushing the two wrenches together at the same amount of force. I'm not able to put a torque wrench down below here. If I put it on here, there's no point, because this, of course, is very tight, because we've just done it up to 250 foot-pounds torque, and so the whole point of this is there's no force that would be transferred through here, so it won't work for torquing up this nut. So what I'm going to have to do is put Loctite on there. It's got Loctite red on there. And second thing is I'm going to approximate the 250 foot-pounds on this lower one, because I am unable to, with the tools at hand, to put a more precise level in. That's good. So that's now complete lockdown. This is tightened up, and we'll just do a little mark through there and through there. This is referred to as a registration mark, which shows exactly where the threads were in case anything were to move. Now in this case, it's torqued wildly beyond the initial configuration where the boat was delivered, and so and we're using very heavy bolts that are able to take that level of torque. So the odds of this coming loose are vanishingly near zero, but nonetheless, it never hurts to put a registration mark on it. This is a done job. We're now ready to clean up and call it a day.
Want to take a look at that bearing and see if there's any play in it like there was in the last one?
The one that we took out?
Yeah, so the last one moved quite a bit, so let's look at this one you just put in and see if it moves.
Oh, I get you.
Yeah.
No. Yeah, you can see, of course, side to side never moves, but this one, it just up and down.
Yeah, it's quite different.
You can see flexing in there with all my strength. Doesn't work at all. Whereas the one that came out of there, when you see it out, you can see it rattles around.
Oh, I can hear it rattling.
Yeah.
So you shouldn't be able to hear any rattling like that?
No, and if you look in there, it looks kind
of ball chewed up a bit.
Yeah, it looks a little damaged,
Yeah.
just generally in rough shape. So probably, definitely worth changing it now, and we're in good shape. The challenge will be, not challenge, it's a fact, we need to get a new one of these parts, because this is the last one in the boat, and neither one of us likes the last thing on the boat ever.
No, we don't.
Exactly. All right, we're done.
Great job.
You can read more about our trip around the world at mvdirona.com, including an interactive map showing our track with a live update of our current location.